Hey guys, welcome to the level 3 probability exam paper from 2021. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try and work it out by yourself, and then unpause the video just to see how I go about answering the questions. So without further ado, let's get started. So looking at this question, the first thing I'm going to do is I'm going to draw a tree diagram, and hopefully that tree diagram is going to kind of help me out as I go along. So the first thing to have a look at is 1/5 of the tickets were sold were early bird. So this is going to be 1/5, which means 4/5 are your general admission tickets. Got the 1/5 from there, and then the second part of it, it says for the early bird 3/4 were adult tickets. So from here I can go into adult, which is going to be 3/4, and then I've got a quarter that's going to be children. Once again, for the general admission, I've got, sorry, just putting that 3/4 there, and 1/5 is there. And then for general admission, 2/3 were adult tickets. So this is going to be 2/3, and this is going to be 1/3. I always recommend drawing a tree diagram. It just makes it a lot more easier to kind of work through with these types of questions. So our first question is predicted at 10% would be child early birds. So we are looking at this branch here. So if we look at it, probability of early bird and child is equal to 1/5 times a quarter. That's going to be 1/20, which is 5%. So you can actually say no, they were not correct. And this question here is worth and achieved. Correct decision with numerical support. So you've got to kind of do both parts there. All right, second question of this. So part B of this question is we've got to calculate the proportion of tickets that were adult tickets. So that means we are looking at this branch and also looking at this branch here. So we're going to say that probability of A is 1/5 times 3/4 plus 4/5 times 2/3. And whatever that is. So I've got 1/5 times 3/4 plus 4/5 times 2/3. That's going to give me 0.6833. And this question is worth and achieved. Cool, next one here. And looking at part C here, as you guys can see, I'm just kind of using that same probability tree for this whole question. Now this question is asking, was it more likely for an adult to be sold an early bird ticket or general admission? So what I'm going to be looking at is, first off, what is the probability of early bird and adult? And then what's the probability of general admission and adult? So if I have a look at probability of early bird and adult, that's going to be 1/5 times 3/4, which gives me 3/20. Then I'm going to look at probability of general admission and adult, which is 4/5 times 2/3, which gives me 8/20. Sorry, that's my mistake, 8/15. Just thinking too fast, too quickly. Cool, so the next thing what I'm going to do is I am going to look at just the difference. Obviously those two probabilities are not the same, because if they are the same, then if I do 8/15, where is it? If I do 8/15 divide, I should probably do this in brackets actually. Let's try that. So I'm going to have 8/15, close bracket, divided by, open bracket, 3/20. I can actually see that it is a ratio is 3.56 between the two of them. So ratio of probability of GA over probability of early bird and adult is equal to 3.56. So we can kind of say that therefore it's more likely that for an adult ticket to be purchased as a general admission ticket. So it is more likely for an adult to buy a general admission ticket. So all I've done here is I've compared the two probabilities, and if you can get one probability, you're going to get an achieved. For a merit, you need two probabilities correct and compared with the correct conclusions made. Okay, next question. So for this situation, there's a couple of things that are happening. Firstly, I'm going to put this as 2021, and then secondly, I'm going to put this as 2022. Now with 2022, they are actually saying the relative proportions of adults are expected to remain for same. So this part of it, we're not really going to change any of it. We're going to leave it as it is. However, if you look at this part here where it says in 2022, reduce the proportion blah 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 to 1/2 of the original 2021 purchase. So that means this is no longer 1/5 and this is no longer 4/5. It's actually half of 4/5, and half of 4/5 is 2/5, which means EB now, early bird, is actually going to be 3/5. So now we've got those two kind of probability trees that are happening. And what we're going to do is we're going to work out what's the probability in the first one in 2021, and then repeat the process for 2022, and then compare the two differences. Now you might be wondering which probability that we are actually trying to figure out. And if you have a look at it, it says the proportion of adult tickets that were sold as early bird. So basically what we're looking for is probability of early bird given that it's an adult that actually purchased it. So we are going to need to do this basically using conditional probability. So we're going to get probability of early bird and adult divided by probability of adult. Now if I'm correct, we actually calculated what the probability of adult is in question there we go, question 1b. We actually calculate the probability of adult. So I'm literally going to just follow that same kind of pattern here. So with EB and adult, so EB and early bird and adult is going to be, what is it? I'm going to have to choose different colors here. So this is the early bird and adult. And again, it's going to be the same for 2022. So I'm going to find out what probability of EB given adult is. So that's probability of EB and adult divided by probability of adult. So as you guys can see here, we've got two things that are happening here. So let me just move this. Firstly, the EB branch, EB and adult, that's going to be 1/5 multiplied by 3/4. And that whole thing is now divided by the probability of an adult, which is actually the pink line here. So with the pink line, for 2021 we had already worked it out, but I'm still going to write it down here. So which is 1/5 times 3/4 plus 4/5 times 2/3. And going to work that out first so that we don't mess up things here. So in my calculator, I've got, in the numerator, I've got 3/20. So 3/20, and that's going to be divided by, we've got 3/20 plus 8/15. It is this ugly looking number here, and we can actually put that as fractions to decimal, which is going to be 9/41, or in decimal we're going to get 0.22. I'm going to repeat the same step for this for 2022 now. So the intersection of early bird and adult is going to be 3/5 times 3/4 divided by probability of adult, which is that pink line. Sorry, I should have actually put that here. So then probability of adult now is 3/5 times 3/4 plus 2/5 times 2/3. And once again, I'm going to put this all in the calculator. So I've got 3 times 3, which is 9/20. 9/20 divided by 9/20 plus 4/15, which is going to give me 0.63, or fractions denominator is 27/43. Now, as you guys can actually see, the probability of early bird, given that they're an adult, is now gone to 0.63 compared to 0.22. So what we're going to write is we're going to write a little statement that says this changes the proportion. This changes the proportion of adult tickets, of adults buying early bird tickets. So grades wise, states that the proportion of adults that are sold as will increase supported by one conditional probability. States that the proportion of adults that are sold as okay. So if you just calculated one of the probabilities, which is just this one, either of these conditional probabilities is going to get you a merit, right? But if you compare both of them and then kind of write this final statement, you will be looking at an excellence grade. Cool. Next question. So for the last question, what we've got here is the aim for 2022 is to increase proportion of all child tickets that was early bird to 30%. So basically what we've got here is probability of EB, given that it's C, is equal to 0.3. Proportion of all child tickets that were early bird type. Were early bird type to 30%. Okay, and now we're being asked to figure out what the proportion of early bird tickets to be sold in order for this to happen. Now that means we don't really have 1/5 or 4/5 here, and as from the previous kind of question, that whole proportion of adults and child is still going to be the same. So what we're going to do is we're going to put down the probability of early bird, which we actually don't know what P is. We don't know what that P is, so we're going to put that as P, whatever that probability is. And then for general admission, we're going to get 1 minus P. So with that in mind, we are going to go probability. We're going to write this conditional probability out. So probability of EB given the child is probability of EB intersect with C divided by probability of C. So with probability of EB intersect with C is going to be that, and then probability of C is going to be this two branches here. So we're going to have to write this down. So we're going to have EB given C is 0.3 equals P times a quarter, because that's what we have for the green line, divided by probability of C is going to be P times a quarter plus 1 minus P times 1/3. And that's equal to 0.3. Now, looking at this, you know, like some people might be like, oh God, I hate algebra. How do I do this? You can actually put this straight up in the graphics calculator and kind of solve it. I am going to show you guys how to do that. So go into menu, go into equation. I'm going to show you how to do this manually as well, so don't stress. We're going to go into solver and we're going to put down 0.3 is equal to, we're actually going to use P here, so we're going to go alpha P wherever that P is. Yeah, there we go, alpha P. But if you, I mean, you can use X. Let's just use X because it's easier. X times 1/4 and that's divided by x times 1 over 4. So we got x times 1 over 4 plus, in brackets, we're going to do 1 minus x multiplied by 1 over 3. Hopefully I've got this all correct. And then if I click on F6, which is the solve button, I end up with 0.36 as my x value. Now this is the correct answer for this question. So it does end up being 0.36, but so that's one way of doing it, but I'm going to show you guys the manual way of doing this anyway. So we've got 0.3 is equal to p over 4 divided by p over 4 plus, I've got to expand the brackets. So 1 times 1/3 is 1/3, and then minus p times 1/3 is minus p over 3. And if I was to carry on here, I'm going to get 0.3 is equal to p over 4 divided by quarter minus 1/3. So I've got to go quarter minus 1/3 because it's 1 over 4. Quarter minus 1/3 equals to that. Oh god, quarter minus 1/3. It's negative 1 over 12. So we're going to get negative p over 12 plus 1/3. Cross multiply. So we're going to get 0.3 times negative p over 12 plus 1/3 equals p over 4. Expand again. So 0.3 times negative p over 12. So we're going to get 0.3 divided by 12 is that, which is the same thing as saying 1 over 40. So we're going to get negative p over 40 plus 0.3 times 1 over 3 is 0.1 equals p over 4. So 0.1 equals p over 4 plus p over 40. I know it's a lot of work, but we'll get there. So we've got 1 over 4 plus 1 over 40. That's 0.275 or 11 over 40. So we're going to get 0.1 equals 11 over 40p. And then p is equal to 0.1 divided by 11 over 40. So 0.1 divided by answer is going to give me 0.3636. Or if you want to write it in fraction to decimal, you could write it as 4 over 11. So you can actually use the graphics calculator to try and work out that answer. But of course, if you're comfortable with algebra, then you can always rearrange this question to get this grade. But yeah, like I said, you can use the calculator, because if I look at the answer schedule, they kind of show the working here and then just jump straight into the answer itself. Now you're not being assessed for your algebraic skills, you're actually assessed for whether you understand this part here. Cool. So this question, correct equation setup, is going to get you a merit. So that would be PE. Okay, so I'm probably thinking somewhere here is probably going to get you a merit, and then your final answer, you will get an excellence here. All right, cool. So that is question 1 done. All right, guys. So for question 2, what we've got is one of those triple Venn diagrams. So I'm going to do that first. Do a whole bunch of circles. All right, so we've got idle, which is going to be I here, E is escapade, and S is serendipity. All right, so 5 of the acts at idle. I'm not going to do the 17, 14, 29, the first bullet point yet. But what I am going to do is do the first one, which is going to be 5 of the acts perform at idle and escapade. So that's this part here is actually worth 5. 3 acts can be seen. I'm going to actually work this one first. 3 acts can be seen at all 3 festivals. So that's going to be 3 here. And remember that the red line we said was going to be 5. If the red little part is going to be 5, then we know that this is going to be 2. So we got 3 and 2. Then it says 13 of the acts can be performed at idle and serendipity. So that's this part here is worth 13. And because we've already got 3 there, this is going to be 10. And if that's the case, then what we also have is, so idle actually offers 17. We've covered, so idle offers 17. So this entire circle is worth 17. We've already put in 15 there, which means we've got 2 more left over. So that's that, 15 left over there. And then what are we going to do for the next part? Alright, so what we've done so far is we've actually covered the yellow idle circle, which is actually 17. Now, what that means is this entire part here, the red area that I've kind of shown here, is actually worth 20, because we can actually say that 37 was the total acts minus the 17 that's idle. Then we're going to get this red zone here to actually be 20. All right, that's something to consider. Now the second zone we're going to look at is just the E. Probably not this color. Let's go with blue here. Now the E part of it, which is this particular zone here. Now E had 14 acts. The whole of E had 14. So I'm just going to do this separately here. So this is the whole of E had 14 acts. So this is going to be 2, this is going to be 3, and this blue little kind of like the semi part of a circle is going to be worth 9. And we're going to repeat the same step for S as well. So when we do that for S, so with S we've got the green zone. Hopefully this kind of makes sense here, what I'm trying to do here. Now with the green zone, this is already 10 and 3. So remember that E was originally 14, and then I did 14 take away 5 to get the 9. The S is worth 29, and if I do 29 take away 13, I'm going to get 16. So 16 is the green zone, and the blue zone is 9. But when I add 16 plus 9, I get 25. But the red zone is only supposed to be 20, and it can't be 25. So what I'm going to do is 25 take away 5. Then that'll make it 20. So that, in other words, there's a 5 of it that's going to get overlapped. Now the blue zone is worth 9. So if I go 9 minus 5, I'm going to get 4. The green zone is worth 16. 16 minus 5 is going to be 11. And I'm sorry I kind of did it this way. It's always a bit tricky to try and kind of explain it from my head to these diagrams. But I think that's the most challenging part that's done. So if we look at the actual question part 1, it says calculate the proportion of acts as idle that are unique to the festival. So in this case, it's going to be 2 out of 17. Now the reason I did this whole the full Venn diagram is we're probably going to need the rest of the statistics anyway, like the rest of the probability anyway. So 2 out of 17 is going to get you a achieved. That's a correct probability. Then looking at the question part 2, which is which 2 festivals have the greatest seeing the same acts. So if we look at it, we've got probability of I and E. We've got probability of I and S, and probability of E and S. So I and E, that's 5 out of 37. I and S, which is 13 out of 37. And then we've got E and S, which is equal to 8 out of 37. And from here we can basically say idle and serendipity, is it? Yep, serendipity have the greatest probability of seeing the same acts. So just writing, because it's 13 out of 37, which is actually bigger than 8 out of 37 and 5 out of 37. So grades wise, one of these probabilities is gonna get you an achieved. So either getting this, this, or this, and then correct right statement, you're gonna end up with a merit. So part 3 of this question is a particular festival attendee can only attend one festival, which is going to give them the highest probability of seeing a unique act. So if we have a look at probability of idle with unique, you're going to have 2 out of 37. Probability of E, whatever that was it escapade? Escapade was 4 out of 37. And then finally, probability of serendipity just on its own is going to be 11 out of 37. So just kind of reiterating. So 2 is the unique act there for idle, 4 for escapade, and 11 for serendipity. So from here, we're just going to say that, what is it? So attendees should attend serendipity, as it has the largest probability of seeing a unique act as well. Yeah, of course, of seeing a unique act. Grades wise, this question is worth it's just an achieved really. So you need to have correct conclusion, and that sorts you out with an achieved. Okay, so question B, part 1, we've got right, calculate the percentage of predictions that were correct. So they predicted and actually attended the festival. We're going to have 80 that were predicted to go to idle and actually attended, 25 predicted and attended escapade, 5 predicted for serendipity and attended the actual festival. So what we've got here is the probability that was correct is 80 plus 25 plus 5 divided by 214, which is going to give us 80 plus 25 plus 5 divided by that's 110 divided by 214. That's going to give us 0.514. As a percentage, we're going to write it at 51.4%. Grades wise, this question is worth an achieved. Finally, looking at part 2 of this question. Part 2 of this question is comment on the appropriateness of the model for predicting attendance with at least one additional calculation. Okay, so I mean, I know in the answer schedule I had a look at it, like they've given us all six of these possible things that could happen. So I'm going to try and kind of show you guys what actually happens with that. All right, so if we look at first off, we're going to look at what are we going to look at? 80 out of 102. So in here we're going to have 102 as the total number. This is going to be 102, this is going to be 72, and then we're going to have 40 there. So if you look at it, so first off, we've got 80 out of 102. So 102 people were predicted to attend Idle Festival, but only 80 of them attended. So 80 out of 102 were predicted to attend Idle. And actually attended. So we're gonna put this as a percentage. So if I go 80 out of 102, I end up with 78.4%. And I'm going to repeat the statement again, but this time it's going to be 25 out of 72, where they were doing escapade and actually attended. Now 25 out of 72 is 34.7%. Then we've had 5 out of the 40. They were predicted to attend serendipity. Sorry, that's just me being very lazy and not wanting to write the whole statements. That's 12.5%. So as you can see, like the percentages are actually quite way off for 2 of the events, but one of the events, it's fairly well, it's higher than 75%, which is good. Now we're going to look at you can look at it the other way as well. So if you look at it the other way, you've got 80, 15, and 2, that's going to be 97. 30, 40, 65, and then you've got 20, 52. So the other statements that you can write is you could actually go 80 out of 97. Attending idle were predicted to attend. And as a percentage, what do we got? 80 over 97, that's 82.5%. And then if you look at the next one, you've got 25 out of 65 attending escapade were predicted to attend that. So 25 out of 65 is 38.5%. And then finally we've got 5 out of 52. They attended serendipity, and they were predicted to attend. So 5 out of 52 is around 9.6%. So what we've really looked at is the probability this model predicted was like 51.4%. But when we look at all these results here, we can kind of see that they're kind of all over the place. Like, I mean, 2 of them are actually above 75%, but the rest is like under 50%. And especially the last one, serendipity, is like... So we can kind of say a statement that the model has low rate of correct probabilities. Low rate of correct probabilities, and for 2 out of the 3 festivals, and for 2 out of the 3 festivals, because if you look at serendipity and escapade, their prediction rates are really quite low. So yeah, that's basically it. Grades wise, merit is for 2 correct proportions calculated. So we've kind of given 6 there, and proportions used to support reasoning about a potential issue with the model. So you've got to, for merit, you've got to use 2 proportions, and you've got to talk about that it's not going to work. And for excellence, you have to actually talk about the low rate of correct probabilities, and also have the couple of proportions up there as well. Cool. Next question. So with this question, there's not really much to it apart from a couple of how you would actually run the simulation, but they actually don't. They actually say not to design the simulation. And I guess what's the purpose behind of the simulation, right? I guess the first thing we can kind of talk about is, I'll actually write this down first, and then I'll actually talk this through. So the first point you could talk about is that this simulation is going to actually allow Patrick to kind of see like the variation in the number of cola drinks that he's going to get, because he's got a sample of 300, and of course we can assume that he's going to have a probability of 1/3 of getting cola drinks. So the whole purpose of the simulation is to see, you know, what would actually happen in this experiment. I guess that's what I would kind of say, something along. And of course, the second point is that by actually doing the simulation, then he can actually compare with what he actually observed, because what he observed was that he got 85 cola cans out of the 300, which again is a probability of 0.2833. And then he can compare with his simulation and what he actually got from in real life. And then you can actually see what's that likelihood of that result happening again, or a lower probability happening again. Now, I have to say, like this, you know, like, I mean, when I think of like the calculus papers that end up doing most of the time, the excellence questions tend to be a lot longer. But in here, it's more about what you know about simulations, and kind of nailing it in a couple of statements. Yeah, it's quite interesting. Answer schedule, it does say discussion, blah blah blah, without numerical support. So if you don't actually have any numbers attached to this, then you're probably looking at a merit. Clear discussion, yep. So the last part here with numerical support given is actually going to give you an excellence. Okay, that's question 2. On to question 3. Alright guys, so for question 3, what we're going to do is we're going to create a little table here, because there's a lot of information here that we've got to try and kind of summarize. So what I'm going to do is, we've got less than 25 years old and 25 years and older. So less than 25 and 25 years and older. Now what we also have is kind of 3 things that are happening: dancing, socializing. I'm just going to kind of do this. So we've got dancing, socializing, and other. Now 700 and of course we've got to put the totals here. So 750 attendants, that's this here, are less than 25. So we can say that this is 750, and then we've got 1,000 altogether. So we can say 250 would be the 25 years and older. Then we have the main motivation of 510 of these is to dance. So we're still looking at less than 25 years old, so that's 510. And then we have the remaining of the younger attendees are evenly split. So if we were to take 750 and take away 510, we've got 240 divided by 2. That's going to give us 120 in each of those, in socializing and in other. So that one is done. For those 25 years or older, we've got 160 are mainly interested in socializing. So that's 160. Of the remainder of the older attendees, 60% are mainly interested in dancing. So now if you think about it, you've got 160 that's already taken. So this is basically saying 60% of the remaining. So this is the 2 red boxes, that's the remaining. So if we actually go 250 take away 160, so that's going to be 90. Basically that's saying that this both of these boxes are going to add up to 90, but 60% of 90 is there for dancing. So we're going to go 0.6 times 90, which gives me 54. And if that's 54, then 0.4 times 90, that's the 36. So as you can see, that 54 and 36 is equal to 90. So that is pretty much, I've set up my table, and now looking at that first part, it says calculate the probability the festival attendee is less than 25 years old and is mainly interested in socializing. So that is looking at this thing here out of 1,000 people. So probability of less than 25 and socializing, interested in socializing, can be said as 120 out of 1,000 people there. So 120 over 1,000 is 0.12, and basically this question is worth and achieved. Cool. Next question. So for part B of this question, I'm actually going to bring in the table again. So just copy the table there. So we're looking at, they're claiming it, organizers are claiming that it's at least twice as likely for younger participants to be mainly interested in dancing compared to older participants. So the probability that we're looking at is probability of dancing given that they are less than 25. And we've also got to work out probability of dancing given that they are older than 25. So we've got to compare these two probabilities here. So given that they are less than 25, that's out of 750, 510 are interested in dancing. So that's the probability for dancing given less than 25. As for dancing given older than 25, we've got 250, and then the guys that are interested in dancing is 54. So hopefully you can see what I got that. So 750 is actually from here, and out of that 750 we had 510 that was interested in dancing. 250 is the number of folks that were actually older than 25, and from that 250, 54 were actually were dancing and over 25 years old. So now what we're going to do is, it is claimed that it's at least twice as likely for the younger participants, right? So if we actually put the probability of younger than 25 over that older than 25, we should get at least 2. So let's have a look. So it's kind of, it's just calculating risk really, but so probability of dancing given less than 25 divided by probability of dancing over 25. So what we've got here is 510 out of 750 divided by 54 out of 250. And when we actually work this out in the calculator, so we're going to put in a bracket, 510 divided by 750 divided by, got a couple of divides there, divided by 54 over 250. Now this is giving me 3.148. Definitely supports the claim because it is actually, it said at least twice. So we can actually say data supports the claim as 3.148 is greater than 2. I'm thinking this is going to be a merit question. Yep. So for merit, you could need both probabilities and the conclusion. So you need this, and the conclusion. For achieved, you could actually just end up with one of these probabilities should get you an achieved for this grade, for this question. Question C, part 1, what we're looking at is, are the event's festival attendees is less than 25 years old and mainly interested in dancing independent. So what we're going to do is we're going to work out the probability of less than 25 first. So probability of less than 25 is 750 out of 1,000. Then we're going to work out probability of dancing, mainly interested in dancing. And probability of interested in dancing is 564 out of 1,000. So just to kind of recap, less than 25, this is all of, this is less than 25, so that's where that 750 is coming from. The 564 is people that are interested in dancing, so that's the total of these two numbers. And then finally, we've got probability of dancing and less than 25. Now that is going to be 510 out of 1,000. So we've got 1,000 people altogether, and that 510 is basically from here, there. Well, kind of get the idea what's happening there. So if they are independent, then if I multiply these two probabilities, that should equal to 510 over 1,000. And if it does, then we can say that they're independent. So what we're going to do is we're going to work out probability of less than 25 multiplied by probability of interested in dancing. So that's going to be 750 over 1000 multiplied by 564 over 1000. And we're going to work this out as, what is this going to be? 750 divided by 1000 multiplied by 564 divided by 1000. That's going to give me 0.423. But the probability of dancing and less than 25 is actually 0.51. No, sorry, I think I just realized I made a mistake there. No, I thought I made a mistake. Actually, no, that is right. 0.51. Now, as you can see, both of these probabilities are not equal to each other. Because probabilities are not equal to each other, you can say that they're not, because the probabilities are not the same. You can say that the two events are not independent. So grades wise for this question, one relevant probability correct is going to get you an achieved. So you could get achieved for either one of these two, or possibly this. All figures calculated correctly and correct conclusion. That's going to get you a merit. So this is up to here is going to get you a merit. All figures calculated correctly and explanation. All right. So there's a second part to this question where we're going to be getting that excellence grade. Now that part two of it, I'm just trying to understand it, asking for the relationship. The only thing you can really kind of mention is the proportion of attendees is that are interested in dancing is actually varied by the group. So it doesn't matter. I mean, based on the group, there's a bit of a difference as to who's actually interested in dancing. So just a simple statement. So proportion of attendees interested in dancing varies by age group. You can kind of see that by the probabilities anyway. So that final remark there is going to get you an excellence grade for this question. It's really interesting how these questions work out in stats. Like, you know, you do all these calculations and then they've got this one little extra line that you got to add in at the end. Anyway, let's go to the next question. So for the last question, folks, what I'm going to do is kind of just summarize some of the answers, some of the reasons that they've actually given here. I think my main kind of thing is that, you know, this is only for the first 1,000 purchases. You know, we don't know the full data for, you know, how many more people are coming. And also one of the main things is that the data is actually just given for online purchases. What happens if people are buying tickets apart from online? And I know it's a bit old school, but if you look at the folks that are over 25 years old, you never know. They might just be like, you know, getting tickets on the last minute. So anyway, I'll just summarize the answers, the answer from the answer schedule, and give you guys some points to kind of discuss. Sorry guys about the verbal diarrhea there, but I just thought I'll kind of talk you through this. So first off, the two main points that I wanted to talk to you about was the data is for like the first 1,000 purchases. So, you know, and the thing is like predictions made from this first 1,000 could be a problem, right? Because we don't know what the early purchases are doing or like why they're buying it. So it could be completely different reasons for attending compared to the guys who actually buy the ticket at venue. So, you know, so you really can't you can't really estimate it. So it could be more or less for those early purchases. And then if you look at the online purchases, once again, making predictions on this might be not correct, because like the online purchases might have different reasons for buying it compared to the later purchases. And so once again, you know, estimating for this particular group could be more or less for early purchases. It's Yeah, I mean, like these, I always struggle with the explanation part of these types of questions. I mean, give me a probability tree with P and a bunch of unknowns, and I'm quite happy to kind of dig away at it. But look, if there is a better way for you to explain this, I would love to hear your comments in the comment section below. Yeah. So I believe that's question D. That's question 3. So that's level 3 probability 2021. Any comments or anything that I've made a mistake, please let me know in the comment section below. But I have to say, it's been a while since I did these papers, and I'm kind of enjoying them. It's quite nice to do stats again after a very, very long time. Hopefully I can punch out a few more of these papers before your exams. Anyway, if you do get up to this part, good luck for your exams. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.